Okay, this is the last of the 6 problems. And again, we're given an angle value of 30 degrees, an A value here of 4, a C value of 4. We don't know what gamma is, we don't know what beta is, and we also don't know what side length B is. So what we do is we set up our law of sines, and so we say, okay, the sine of 30 degrees over 4 has got to be equal to the sine of gamma over 4 as well. So this over here gives me 1/2 divided by 4 is equal to the sine of gamma over 4. So 1/2 is equal to the sine of gamma. So what that says is that gamma is equal to the arc sine of 1/2. So what angles are possible values for, remember, gamma here has to be between 0 and 180, actually between 0 and 150, because we already are using 30 degrees here, and there's only 180 degrees in the triangle. So if we're trying to solve the triangle, let me draw out your unit circle again for you. Okay, so there it is. Now, this over here on the right side says to find an angle whose height value is 1/2. Well, that occurs over here. So length of 1/2. That angle, okay, so that possible angle for gamma is 30 degrees. So at 30 degrees, the sine value is 1/2. Another place between, now remember, gamma is stuck between, it can't go any lower than 0, but it can't go any higher than 150 degrees. Because if it goes higher than 150, we've got more angles or more degree measurements in the triangle than what we can have. So the other possibility, the other place where sine is positive 1/2 is over here at an exact value of 150 degrees. But let's take a look at this. If gamma was 150, then I'd already used up all my 180, so I wouldn't have anything left for B. So we really need to restrict this to strictly less than. So notice that even though the sine value of 150 degrees is 1/2, we can't use it because it would give us too many degrees in our triangle. So unlike the last example where we had 2 possibilities for gamma, this one we only have 1 possibility, and that possibility is a 30-degree angle. So this guy must also be 30 degrees, which means this is isosceles, right? We have an isosceles triangle there. And we can finish solving. That gives us a beta value. If these guys are both 30, then that gives us a beta value of 120 degrees. Okay, because 120 plus 30 plus 30 is 180. And if beta is 120, then we can figure out what B is by taking the following. The sine of 30 over 4 is equal to the sine of 120 over B. So B will be equal to 4 times the sine of 120 over the sine of 30. And if we do some calculations here, this is 4. The sine at 120 degrees is square root of 3 over 2. And the sine at 30 is 1/2. So this is 4 square roots of 3. Oops. Let's just do it out this way. Square root of 3, multiply that answer by 4. So 6.93. The other way to do it is just to go ahead and plug this into the calculator and get our values out. So that'd be the sine of 120, multiply that guy by 4, okay, and then we're going to divide that guy by the sine of 30, and there's our 6.93 roughly. So this guy right here is 6.93 for its length, and it should be longer than these two guys here because beta is the larger angle. Now it's not necessarily twice the length just because the angle is twice as much. I shouldn't say twice as much, 4 times as much.